All right, thank you for joining EMX for today's webinar on our single cut virtual loop detector. So my name is Cameron Moran and I will be leading today's presentation. We will take the next 15 minutes to present the newest product offered by EMX. So please save your questions till the end where we will take the time to answer them all from the chat. So the product we will be discussing today is the Magneto-Resistive Vehicle Detector, the LRS. This is the fourth product version EMX has released utilizing this technology. So why is this product important and why should you care about it? So the LRS significantly cuts down on the installation time compared to that of a traditional loop. This will add up to more money being made on each install and potentially more installs each day. So over the past year, we have redesigned the LRS system from its predecessor, the CS303. The product has undergone a complete rebuild, followed by extensive field testing with overwhelmingly positive feedback. So during today's presentation, I'll be walking you through the updates to the system, as well as installation, configuration, best practices, and tips and tricks for the LRS. So first, let's take a step back and let's look at what's involved with installing a traditional induction loop system, including components as well as what all goes into that installation. So the components would be the loop and the loop detector. So EMX's options are pictured here. When it comes to a loop, you could use a preformed loop like the one we have shown, or you could go through the process of creating and installing your own loop. This would then connect to the vehicle detector, which would be responsible for reading the loop and relaying that activation or presence to your operator. So this type of installation, when done correctly, is very reliable, but does present some challenges. So the challenges with this install really come from the loop itself. A traditional loop would require 9 saw cuts. This is very labor intensive, and due to continually updating OSHA safety requirements, this process is becoming more and more time consuming and expensive. Another concern of customers is the poor aesthetics this type of an install creates. So unless a loop is being installed prior to pouring of asphalt or concrete, you're left with an eyesore and probably even more problematic, an upset customer. Okay, so when this system was designed, it was done so with the installer in mind. So this is a recurring theme across all EMX products, from detectors with multi-voltage to photo beams able to work on all monitoring methods. We are constantly looking to make sure the installation process is easier. With the LRS, we're eliminating the majority of cutting involved, so the system would require only a single saw cut. As we will discuss later in the presentation, in some cases, no saw cut is needed at all. So this provides a much cleaner installation with far less labor involved. So as you see pictured here, we have an example of what a traditional loop would look like as far as it's cutting into the pavement or roadway, and then an example of what that LRS would look like. So in this example, we have a diagonal cut across the drive path or driveway. You could also do straight across to make it look like a seam in a driveway as well for a more aesthetic installation. So we also offer an easy to configure system with a C1 controller. So the controller uses our proprietary Ultimeter display, allowing for a visual readout of the LRS. With dip switch settings, we can also fine tune that detection field to meet your specific application. So what makes magneto-resistive technology different than other products sold today? So with this technology, we're looking for ferrous metals within the detection zone created by the sensor. So this would typically come from the vehicle's frame or engine, and typically we're looking for steel there. So this system has the ability to detect moving vehicles as well as presence. So this allows the sensor to detect an object as long as it's in the field, and even allows the system to detect only vehicles once it has come to a complete stop if that application calls for it. The system also has the ability to set for pulse on entry, pulse on exit, with just a simple dip switch setting. So what we are seeing as the industry evolves is a moving away from traditional loops installs for something that is far less time consuming and easier. The LRS is up to that challenge. On the right, you will see a good representation of what that sensor field is. So it creates this bubble or dome area. Once installed, the system is calibrated and begins to look for changes in the magnetic field caused by that ferrous metal or ferrous metal objects. So this field can be adjusted to meet your application. The LRS, as I discussed before, uses the same detect on stop feature found in our vehicle detectors and is unique to EMX products. So this gives us the ability to only detect a vehicle once it has come to a complete stop. Where this will be applicable is if you're dealing with cross traffic or you have people that are trying to speed through a gate or beat the gate, you can make sure they're coming to a complete stop so they're not going to hit that gate or potentially the gate hit them. As discussed before, the altimeter display gives us a visual readout of what the sensor is seeing. So this simplifies the installation and troubleshooting process. So next, we're going to look at the different components that make up that LRS kit. So the system components, they can be sold separately, but we now offer them as a complete kit. So this simplifies that ordering process. So first, you will need to select the style of sensor that best fits your install. We have two different options available for the sensor. So the first option is the LRS DB or direct burial. So this can be installed above ground or in the roadway via a saw cut, and then you would just need to core out to drop that small probe in. The other option is the LRS FP or flat pack. Both sensors utilize the same technology and components, just in a different housing. So the flat pack is meant to be installed via a saw cut and placed in the roadway where you want your activation to occur. These would then connect to our C1 control. So this serves as basically our vehicle detector for the system and gives you the ability to make all your necessary adjustments. We also have the ability to add an additional or an optional logic interface. So this would provide the ability to extend your detection range as well as add like AB logic with multiple systems or multiple LRS systems on one application. The next innovations and improvements we've made to this system. So when we redeveloped the LRS system, we looked to rebuild the entire product and improve all aspects. So starting with the sensor, we improved upon the physical materials used. So this made the system far more resilient to subtle movement on the ground when installed. So this was primarily accomplished by updates made to the lead wire and the lead wire coating. Next, we redesigned the electronics on that C1 controller to upgrade the firmware and other electrical components. So this made for more reliable readouts on the sensor, as well as eliminated false detections. All right, so looking at the LRS in use. So when we look at where the system can be utilized and installed for replacing a loop, the short answer really is it can be installed anywhere a loop can be installed today. So the first example of that is in applications or automatic gate applications. This can be used for both new installs as well as old loops that have gone bad and need to be replaced. The other option we have is automatic overhead doors. So this can be used in a number of applications when it comes to overhead doors. In the past, we've used these a lot in car dealerships and service areas. In these type of applications, often you're seeing tile floors in the interior. So this system could potentially be cut in along a grout line with little to no damage to the existing floor to make for, again, a much more aesthetic install. Parking barrier gates, so just as a loop would be utilized, we can use them for triggering free entry, free exit, or also activating a garage kiosk. And then in drive-through applications. So loops are often used to notify as a vehicle enters the drive-through, as well as tracking throughout that drive-through process. So we could use these for those also. So when installing the sensor, we have a number of different options as far as how the system can be installed and what materials it can be installed in. So the flat pack or direct burial sensor could be installed in pavement, with that example shown here on the right. Also in asphalt. And then with the direct burial sensor or DB, we can install that above ground in above ground applications as well. So the key in either install in the system needs to be in a fixed position and secure. So once that install has occurred, movement in the system, once it's been installed and calibrated, can cause changes in the magnetic field of the system and could cause false detections or false readings. So make sure that is fixed and not moving at all once it's been put into place. So as we discussed before, the detection area created by the sensor, again, here's a visual representation of that pattern. The zone measures 10 foot in diameter and 5 foot in radius. And this again is a good representation of it. Know that once that is installed, you're getting that full dome shape. So if we're installing above ground, that's also going to be on the other side of that bollard post. So keep that in mind when you're doing your initial install to account for if there's going to be traffic or moving metal objects on the other side of where you're hoping to have your activation, to ensure that you're not going to get false readings. So if the detection zone is too large or overlaps in the application in which I had said, other things that may cause issues, you can fine tune that with our X, Y, and Z axis. So this adjusts for your width, your height, and your depth of that detection zone. So here is a video that is basically showing that. So we have our height, width, depth with those 3 dip switch settings. As the gate is coming closed, we see that the sensor is a little close to the gate and it's causing a detection on the C1 controller. So in that, what we're able to do is we're able to adjust one of those dip switch settings to no longer see that gate, and then as the vehicle comes up, it detects the vehicle and causes the gate to activate as it should. So again, playing through. Gate's coming closed, we're seeing it. We're going to adjust it out via dip switch and ensure that we're not going to see that gate and the application is going to work appropriately. All right, in this next video, basically what we're showing here is the ultrameter display and how that can be used. So as the vehicle were to come up, we're going to get a readout on that sensor. On this video, it basically jumps straight to 4, but what you would typically see is a countdown from 9 down to 1 essentially, depending on how much of that vehicle is detecting. As far as your initial install, what we would recommend is driving your vehicle up, getting out, driving the vehicle up to where you would like activation to occur, look and see where that detector is reading, and then adjust your potentiometer accordingly so it'll activate at that point every time. Another way this can be utilized is for troubleshooting purposes. So if for any reason there is an object in the path that is causing a false detection, or we're getting a reading on the sensor, like in the example of the gate, then we can see that, and it's much more easy to diagnose and correct those issues with that visual readout. All right, and in this third video, basically what we're showing is how that detect on stop feature were to work. In this example, we're using an overhead door. So it's making sure this vehicle is coming to a complete stop prior to activation occurring. So the door comes open, and then as we see cross traffic coming through the pattern, we are able to discriminate that and make sure we are not causing any type of detection. So where this would really come into play is if, use the example of like a parking lot, and we have a barrier arm, and we have a busy roadway, we can ensure that as those vehicles are driving past, we're not going to cause any type of detection. We're only going to detect once they've pulled in and come to that complete stop. So now let's look at the system and how that will wire up and adjustments are made. So the C1 controller serves as the vehicle detector for the system, as we said earlier. If you look at the pins on the board here, you will see where the sensor would wire in and where you would wire back to the control. So you could wire this in as normally open or normally closed, depending on your operator. The sensor itself has a total of 5 wires. That would be for these bottom 6 pins. And then the top 4 or 5 would be your 2 powers, as well as your normally open, normally closed, and common. Those are where you would wire back to your control. All right, in this illustration, we show for when you're doing the actual installation, the dimensions of the sensor. So when looking at the flat pack, you would need to be at least at a 2-inch depth to be below that roadway. And then as far as the width of your saw cut, that 0.313 inches. If we're doing the DB, you would do that same saw cut, but you would need to core out to drop that small probe in. As far as the epoxies in which we, or sealants, I'm sorry, in which we would recommend, an epoxy or a rigid poly. All right, and this is probably one of the biggest issues, if there is an issue in the initial install, it's with the sealant that's used. So make sure once that sensor is laid in there and we apply the sealant, it needs to be below the roadway to prevent sensor damage or false readings. So if we have it bubbled over or above that roadway, every time someone were to drive over that or be on top of it, basically we're applying pressure to the sensor, which again could possibly damage the sensor as well as cause movement in that sensor, which could cause false readings. So we need to make sure we're at least flush or below the roadway. So additional components can be utilized here. We talked briefly on that logic controller. So this is an optional addition that we can add. Really what this allows us to do is to have multiple LRS systems. We can use that again for AB logic as well as extending that detection zone. So because the detection zone is typically 10 feet, we can extend that as far as 20 feet. Those patterns are able to overlap, so you could do anywhere in between that as well. When ordering the system, they come in a standard 50-foot or 100-foot lead. These are included with the system. If you were to need to order a custom length or a longer lead length than that, those are available, but those again would be custom, so just account for more lead time to get those ordered. All right, and this is that C1 controller where our adjustments are made. So working our way down, we see our dip switches. So with these dip switches, we're setting for our 3 access points. So that's where we can adjust and fine tune the actual size of that pattern. Our detect on stop feature, pulse on entry, pulse on exit, those can all be done with those dip switches. Next, we have our potentiometer. So basically where we're adjusting this is where we want detection to be reached based off of the readout of that ultrameter display. So with the ultrameter display, basically like we talked about before, we're given a visual readout of what the sensor is seeing. So as the vehicle comes up, counts down from 9, and then you set basically where you want the detection to be achieved. And then we have the calibration button below. So the calibration is important for any changes that we're going to make to the system or adjustments, or if anything has been introduced, we want to make sure we're doing a recalibration. Okay, so now that we understand how the system works and how it wires in, let's take a look at some of the more subtle installation practices that can ensure a great install. So it's important to take into account that some vehicles, for example, like the newer Ford trucks, they come with aluminum frames. So the LRS requires a ferrous metal such as a steel for accurate detection. So these types of vehicles will typically have enough ferrous metal in them in the engine and other parts of the vehicle to achieve that activation or detection. But if you are expecting these types of vehicles will be used at your install, sensor placement is key. So as these vehicles will be activating slightly different than what a standard vehicle would. So the sensor may need to be placed farther back. Again, this is where it's important to kind of drive test that install before we actually make our cuts into the ground. Okay, once the sensor is installed in the ground, the epoxy and sealant needs to be flush with the road or slightly below it, just as we talked about. If it's above the road, this will cause pressure in the sensor, may cause movement, false detections, and possible damage to the system. All right, the sensor needs to be fixed and stationary for accurate detection and activation too. So if the sensor has movement, this can trigger that false detection. That's why it's important when we're doing our cuts and we're sealing it correctly to make sure it's fixed. It's especially true as well when we're installing into conduit, as the sensor is not as snug as what it would be into concrete. So in these type of installs, ensure that the sensor, it's not able to move. All right, and the calibration of the system is important as well in setting a baseline for the environment. So when changes are made to the system or objects introduced like a new gate or a garbage can or dumpster, it's important to do that recalibration to make sure that it kind of retakes that picture of the magnetic field as its baseline. All right, in summary, the LRS is a great solution for any application where traditional loops are not feasible or wanted. These are great because they add additional control and functionality when necessary. The LRS is available for purchase today. As we wrap up today's webinar, if you have any additional questions on LRS or any other EMX products, please reach out to Darlene Brooks or myself. Our contact information is listed here, and we'll be happy to be of help. Right, you can also visit our website at emxaccesscontrols.com for general product information, or follow the link above or the link on the presentation for specific literature on the LRS. All right, thanks again for your time, and we'll take a look at the questions from the chat now. Please take those questions out, and we will make sure to answer everyone. Also, if anyone was not able to attend today's webinar, any of your colleagues, they can attend the webinar that we'll be hosting, the same one at 2 o'clock today Eastern time. And also we'll be looking to post this on our YouTube channel as well for future viewing. All right, so the first question that I have, and Drew, you might need to help me out with this as far as send these directly to me so I make sure I'm getting them. But the first question I have is in regards to cost and what would be the cost of this system. So if you are a customer currently of EMX, I would suggest reaching out and we can provide you with that pricing. We also send newer price lists out for our December 1st price list. This product should be included in that as well. If you are not a customer of EMX today, I would reach out to your local distributor and they can provide you with that pricing. All right, another question we have here is how do these sensors perform in detecting motorcycles? So as long as they have ferrous metal, that would not be an issue. Again, I would recommend just drive testing those for your initial install to make sure we're calibrating them, because we can adjust those down and have those up as high as a 9 or an 8 in that detection. Those should detect motorcycles no problem. All right, more information in regards to that logic controller as it pertains to counting vehicles for a parking guidance system. That was something I'll have to look just a little bit more into. I know as far as our drive-through applications, we're utilizing this sort of a system where it's counting the amount of traffic that's going through. So I would assume it can be tied into a system to do that. I'm not sure if it's able to do that on its own. Actually, I know it's not able to do that on its own, but it could be tied in or integrated into another system to be able to do so. Another question, is there credits potential for this webinar? That's something we didn't look into, but if that's something you're interested in, you can reach out to me directly. My email's on there and we should be able to provide that. So can 2 sensors be connected to 1 controller? So no. So if you were going to be utilizing more than 1 system, we would need to make sure we're using that logic controller. All right, so if this is used in a multi-story parking structure, can the Z-axis depth be set to eliminate picking up vehicles on the level below? Absolutely, absolutely. So by adjusting those access points, we can shrink that pattern down to ensure that you're not going to get false detections from below. And again, because we have the most it would really reach down or should reach down is 5 foot. So by adjusting that Z-axis, that should shrink it to the point where you wouldn't run into any problems. So what is the chief difference between the old CS303 and the new LRS system? So the main difference really with the system is just its complete redesign for basically product improvement. So the functionality in theory is exactly the same, but one of the biggest concerns that we have with that system is how changes if it wasn't installed properly, or if we had flux or movement with that sensor, false detections would occur. And with the new changes and updates we made to the system, we have basically completely eliminated that. So as long as we're not getting continuous pressure, like we talked about with the epoxy, then the sensor would work great and you shouldn't have any problems. All right. What is the maximum limit for the axis? So something to keep in mind when we're making our adjustments, it's not going to be, it's not an exact measurement as far as how we adjust. Basically, we shrink that as we adjust those access points. Instead of having that sphere, it kind of changes the shape of it. So it might be more elongated. You know, imagine if you're just changing the width and how that would possibly affect what that pattern looks like. So it's not an exact science as far as the max limits or how much that would adjust. It's basically turning it on and off. So you would be adjusting a couple feet. If you have 5 feet, you might be able to adjust it down by 2 feet on your height, width, and depth. All right. This question I have here is, if this detects presence, can it be used as a safety loop? So yes, as long as your control has the ability to inhibit that system through the closing cycle of the gate, you know, obviously it's going to see that gate through closing, but this could be used if someone were parked in the threshold there. All right. There's a question here in regards to the specific types of sealants used. That's one that I'll need to look a little bit further into, and I can make sure I follow back with you on that. And also, for some of these questions, I'll also throw this out there. As we post this to our YouTube channel, we'll try and go through and answer any questions that we're not able to answer in the chat today. Yeah, so the question here, the place where you install the LRS automatically becomes the center of that magnetic field, and that's correct. Yeah, so it's gonna, that would be the center of it. So where you place it is important, and typically you're gonna place it in the center of where you want detection to occur in that roadway. All right, so what is the warranty on these systems? All of our systems come with a 2-year warranty, so that would apply here. So does this come with an A and B relay? So that would apply when using the logic, the additional logic module, and that would come with 2 separate relays because we would be tying in 2 separate systems. The question here is, do you offer the power supply for the detector? So power would be coming from the operator itself. So as you wire this into the operator, it provides power, which then provides power to the sensor. Yes. So the question here is in regards to cost and how that compares to your traditional loop and loop detector. Cost would be similar, yes. So really where your savings is going to be in that initial installation. So how many sensors can be connected to a single system? And really, it's just going to be the 2 using that logic module. All right, can 2 be used in a wider driveway to mimic a wider conventional loop? And yes, they could be. So we're basically, we can extend that widthwise or lengthwise, you know, depending on the application. All right, and this question is in regards to the lead lengths and how that could be incorporated when we're doing 2 sensors and using that LRS in combination for the detection zones. So that's something to keep in mind. So if you are using a 50-foot lead length for your first zone of detection, and then you want to extend beyond that, then you would need to order 1 50-foot length and 100-foot length to ensure you're going to have enough space to extend that out beyond that first 50 feet. All right, so there's a couple other ones here. I got 2 more here that I'm going to read through, and then the other ones, obviously we have all the names, everyone who has reached out, and we'll make sure we go back through and answer any questions we didn't answer on this chat. Again, you have if you didn't say something in the chat or you think of something later, please feel free to reach out to me via my email that is shown here in the Q&A, and we'll make sure we get that taken care of for you. So in regards to power, 12 to 24 volts AC/DC, yes, that's correct. And then can the sensor be mounted on the ceiling? It could potentially, but the clearance would have to be very short. And then, you know, using the example of a parking garage, if we have vehicles up above, we might see false detections there. So I would avoid mounting on the ceiling if possible. All right. Well, I thank you all for your time enjoying today's webinar. Again, feel free to reach out to me via email, and anything we didn't answer in the chat or ones we weren't able to answer, we'll make sure to reach out to you individually to get those taken care of. So have a good day, and thanks for your time.